The Givebutter platform has grown into a major player for nonprofit fundraising, offering a completely free, open, and public API that sets a high standard for accessibility in the sector. Developers and organizations looking to sync data, build custom dashboards, or automate donor workflows can easily access endpoints for contacts, campaigns, funds, and transactions. However, working with the system reveals specific architectural boundaries, missing methods, and operational restrictions that can trip up development teams if they are not anticipated early in the integration process. A primary constraint involves recurring plans, which are fundamentally read-only through the public interface. While developers can observe plan data or receive webhooks when a recurring schedule updates, pauses, fails, or completes, it is impossible to programmatically create, cancel, pause, or resume a recurring donation plan via code. When a donor needs to modify their recurring schedule or when an organization wants to set up a subscription plan on behalf of someone through an external application, the operation cannot be executed via the API, forcing teams to redirect users back to the native web interface. Another notable limitation appears in transaction management and contact workflows. While transactions and contacts support creation and updates, transactions cannot be deleted through the API, and certain critical properties lack dedicated update triggers. Specifically, changes to contacts or transactions do not consistently fire automated native update hooks, meaning background sync processes or external CRM integrations often have to rely on active polling rather than event-driven architecture to catch subtle modifications. Furthermore, pagination defaults to a standard offset model rather than advanced cursor-based navigation in practical execution, which can introduce performance overhead when pulling massive historical datasets across very large nonprofit accounts. Rate limiting is generally generous for the nonprofit technology space, capping traffic at 500 requests per minute, with excess requests returning standard throttling codes. Even so, successful responses do not include remaining budget headers, making it difficult for automated scripts to dynamically throttle mid-run without tracking execution counts locally. Recognizing these boundaries, from immutable recurring rules to polling requirements for specific updates, allows engineering teams to design resilient architectures that successfully bridge Givebutter data with external software ecosystems.